Welcome to the e-learning course for Asprova hands-on training. 2C. Technique to shorten lead times and eliminate late deliveries. Starting Asprova. Click on the Start button to display the Windows Start menu. Select Programs, Asprova APS, Asprova from the menu to start Asprova. Open the project file. Select File, Open from the main menu and select AS2 A5.AR4 from the folder Basic 2A to 2C to open the Asprova project file for this training section. In Asprova, there are various features for shortening lead times and eliminating late deliveries, which you can use for the schedules you created for Asprova. Let's try to use some of those features. In this data, only master data for item A is specified. We will slightly extend master data for item A and add master data for items B and C. First, in the integrated master for item A, add another candidate resource for process PR, so that we have two resources, PR1 and PR2. Next, add master data for items B and C. You can input the data directly to the table, but you can also create the data more easily by copying the master data structure of A, which is similar to that of B and C. To copy the master data of A, right-click on item A in the integrated master editor and execute New Item from the pop-up menu. In the Add New Master dialog that appears, enter B in the New Item field. Select A from the drop-down list from the Copy Master from Existing Item field. Then click the OK button. Item B is created in the same structure as item A. Manually modify values of B that are different from A. First, let's just set the resource to PR2 and PR3. The production values are 10 MP and 2 MP. In the same way, add item C and manually modify values that are different from A. Set the new item to C. Set the Copy Master from Existing Item field to A. The resources are PR3 and PR1. The production values are 6 MP, 10 MP, and 3 MP. Next, let's add the orders. Change to the order table. We are going to add 10 manufacturing orders. Let's use this opportunity to practice some input methods. In Asprova, you can quickly input a large amount of data by using features such as copy, paste, and autofill. You can perform input and editing operations more efficiently by using some of the keyboard shortcut keys shown. Let's practice some of these by inputting some orders into the order table. We can quickly enter the order code, like 01, and then use Ctrl D to copy the value above. After we've entered the 10 orders, we can grab the bottom right-hand corner of the first code and pull, dragging it to cover all 10 orders. And when we release, the autofill will automatically fill it in with the order codes in sequence. In the same way, for item, we can also specify a sequence of A, B, C for the items to be produced. And then, if we select these 3 items and drag the bottom right-hand corner, we can also fill in the items as well in the same way. Next, we will set the LET of the orders. Set the first order to 2003, October 10th, 12 o'clock. Select the field and drag down on the bottom right-hand corner. Now we can simply adjust these values for the different LETs that are applied. Next, let's specify the order quantity. First, let's set them all to 100. However, there are 4 orders that have an order quantity of 200, starting with order 4. We can use Ctrl C to copy this value, and then Ctrl V to paste it into the suitable locations, where the manufacturing order is 200 order quantity. Next, we will set the order priority to 95. Grab the bottom right-hand corner and autofill all of the priority to 95. Finally, set the display color. Set the first order to 2, the second order for 3. Select both orders and then drag down on the bottom right-hand corner to fill in all of the orders with a sequential number of display colors. Next, let's specify the display colors and display orders for resources according to the process flow. Change to the resource Gantt chart. Pull back the slider to reveal the resource table. Let's reduce the height of the resources. Scroll to the right to find the display color column. Set PR2 and PR3 to the same color as PR1. Set the display order so that PR1, PR2 and PR3 are consecutive. And finally, set it that CK1 is last. We can redraw it with the new order by pressing the function key F3. After setting the display color and display order, return the slider to its previous position. Let's reschedule and check the result of rescheduling in the resource Gantt chart. The results of the schedule are also displayed in the message table. Let's open up the message table. You can see that one of the messages shows that the average lead time per order is 4.55 days. You can also see that there are 5 late manufacturing orders. Using a couple of features, we will try to eliminate the lateness and shorten the production times. First of all, let's try to eliminate the lateness by changing the working time. As you can see from the assignment status displayed in the resource Gantt chart, one of the reasons for the lateness is that the available time of resource CT1 is not sufficient. So, let's increase the available time of CT1. First of all, let's open the shift table. Let's add a new shift called S2. Let's copy the shift pattern above with Ctrl D. Shift 2 will have 2 hours of additional overtime. After we've set the shift code, return to the resource Gantt chart. Select resource CT1. Click the right mouse button to bring up the body part pop-up menu and select Shift S2. We've now changed the shift for CT1 from S1 to S2. Open the calendar table. A new calendar record has been added for resource CT1. Return to the resource Gantt chart. Reschedule. If you check the message window, you will see that increasing the working time of resource CT1 resulted in reducing the late manufacturing orders from 50% to 30%. Next, let's try to eliminate lateness by splitting the manufacturing orders. We will split some of the manufacturing orders so as to shorten the production lead times and eliminate the lateness. Splitting manufacturing orders should shorten the lead times, but let's see if this eliminates late operations as well. Return to the order table. Split each of the orders, Order 4, Order 6, Order 8 and Order 9, with production quantity of 200, into 2 orders with quantity of 100 each. There are several ways we could split the orders. One of the ways you could do this is to first select those orders that have an order quantity of 200. By clicking the right mouse button over the order quantity 200, we can filter the orders so that only those that have a quantity of 200 are displayed. Next, copy and paste these 4 orders. Press Ctrl C to copy. Press Ctrl V to paste. Then we can change all of the orders to quantity 100 like this. Ctrl C to copy, and then Ctrl V to paste. So in one go, all of the order quantities are set to 100. After that's done, all we need to do is make sure that the order codes are different. At the moment we have 2 order 4s, 6s, 8s and 9s. Make the first set of 4 orders A and the second set of 4 orders B. Finally, remove the filter to display all the orders. Then put all the orders back into order by double-clicking on the order code header to sort the orders. Return to the resource Gantt chart. Reschedule. You can see from the result of rescheduling that by having split the orders, the production lead times are shortened compared to the previous schedule, and the lateness of order 8 in process B20 has been eliminated. However, some of the lateness still remains. Trying to eliminate lateness by splitting operations. We will split some of the operations so as to shorten the production lead times and eliminate the lateness. You can shorten production lead times by splitting operations and assign the splitting operations to different resources. This should help eliminate the late operations that still exist. Let's divide the operations for the second process into two and assign them to two resources in parallel. You can split the operations by selecting the operations and specifying the split number and the split parallel number in the Properties window. However, let's try to do this using the operation table. Open the operation table. Select Operation. So we only want to set the split operations for process 2. So let's select only those processes that have a process number of 20. Right-click to bring up the pop-up menu and select Filter Equal. Now we only have the operations for process 2. Scroll to the right to find the properties for splitting. You can see that we have the split number and split parallel number. Specify 2 as the split number and also 2 as the split parallel number for each of the operations. Enter 2 and press Ctrl+C to copy, and then on the column header, Ctrl+V to paste. After setting the split number and the split parallel number, return to the resource Gantt chart. Let's change the width of the day column so that we can see more of the chart. Reschedule. The split operations have been assigned to two resources. As you can see in the resource Gantt chart, by having split the operations, the overall production lead time has shortened and lateness has been almost cleared. However, there still remains lateness with the order 9B in process PR and CK. Trying to eliminate lateness by changing the time constraint methods. We will change the time constraint method so as to shorten the production lead times and eliminate the lateness. Let's change the time constraint method to make the previous process and the current process overlap and see if it will shorten the production lead times and clear the remaining lateness. Return to the Integrated Master Editor table. We need to change the time constraint method. Scroll to the right and you can see that currently the time constraint method is set to ES. We need to change the time constraint method of all the items to EES for the second process, PR, and to ESE for the third process, CK. To make it easier to see which time constraint methods we need to change, let's filter the Integrated Master Editor to show only the use instructions. Click the right mouse button over the use instruction to bring up the pop-up menu. Select Filter Equal. We're going to set the time constraint method of the PR process to EES and the time constraint method of the CK process to ESE. Currently, the time constraint method is set to ES. This means that the current process starts after the previous process is finished. By setting the PR process to ESE, the items from the CT process can be output separately to the PR process based on the values set in the split number and split parallel number properties. In the same way, by setting the CK process to EES, the items that have been split for the PR process can be input separately into the CK process. Change the time constraint method of the PR process to EES. change the time constraint method of the CK process to ESE. Use Ctrl-C to copy the time constraint methods of these two processes. Then use Ctrl-V to paste them into the same processes for the other items. At the same time, let's increase the split number for process PR from 2 to 4. Return to the operation table. In the same way as before, change the split number from 2 to 4. After changing the split number, return to the resource Gantt chart. Reschedule. By changing the time constraint methods to ESE and EES, operations of each process now overlap. This has shortened the production lead times, and the remaining lateness has been cleared. Let's take a closer look at how the operations have been scheduled. You can see here how the operations for the PR process are split into 4, with 2 operations running at the same time on the 2 resources PR1 and PR2. Let's check the production lead time in the message window. Comparing to the message we checked after the first scheduling, which said average lead time per order 4.55 days, this time it says average lead time per order 1.73 days, meaning that the lead time has been reduced by approximately 60%. And now there are no more late operations in the schedule. This is the end of Asprova hands-on training 2C. Thank you for watching.